In order to get that signal marker to appear in the right position, you have to generate that planet and the patch of terrain around it, and then the buildings that are on that patch of terrain, because that building will flatten the terrain. Then you have to go and work out what type of the terrain is, generate all the terrain and generate all the noise, in order to then go and work out the position and whether or not that marker can even actually exist there. A lot of the time, when people are deciding to do that, they're making the wrong decision. They don't actually know if it's going to be generalized yet. And then at the opposite end, you then got people accidentally creating a key piece of technology, which they initially wrote just as a throwaway prototypey piece of code, which then ends up being this load-bearing system that lots of other people are using, but the internals of it have never actually been coherently thought through.
This is a conversation with Simon Carter. This is my best British pronunciation. Simon worked for the famous and cherished game studio from the UK, Bullfrog Productions, and went on to founding Big Blue Box with his brother Dene Carter, the studio that made Fable games, Fable. Fable franchise. We talk about technical side of making games, both the hardcore development for early Xbox 64 megabytes of RAM, but also how his work changed when he was in charge of the tech for the entire studio. Simon Carter, everybody. Tell me a little bit about your beginnings and also about Dene Carter, how you both started in game development.
Yeah, so my earliest memory around games was my brother Dene, who's 5 years older than me. He got a ZX Spectrum for Christmas, I think, when I must have been 6 or 7. So 1982, 1983. He quickly sent it away to go and get, he got the 16K ZX Spectrum. We sent it away to go and get the 48K ZX Spectrum in order to play the next gen latest games. And so I have very early memories of Dene playing games like Manic Miner, Jet Set Willy, on a black and white CRT TV. And I would just sit kind of next to him watching him play these games, and then later on we'd start playing multiplayer games like we played a lot of Chaos, Julian Gollop games, Chaos, Battle Cars, which were multiplayer turn-based games that we could play together. And then Dene got very into games. We used to watch Tron. It was kind of the era where games seemed to be like the next world that people could build and then you could go and inhabit. It was wonderful. So Dene started getting into making games seriously, and he released a game called Rockman when he was 15 or 16, which was published by a company called Mastertronic. And it was he loved a game called Boulder Dash, and so he built this game when it was the first, because we only had a black and white TV, because we were quite a poor family. We only had a black and white TV. The first time he actually saw the game in color was when he saw a review of it in a magazine.
Really?
So he made the entire game in monochrome, and he kind of guessed at the colors, going, green, sure. And built this, and then it came back, and then the review said, yes, the game is good, is very good fun, but it's quite garish. yes, it is. So yes, that's kind of how I fell into it through Dene.
Hi everyone, let me take a break to thank members of the show who made this conversation possible. Members get earlier access to videos, including longer unedited footage from live streams, as well as they're invited to our private Discord server. If you want to support the show, there is no better way than becoming a member on YouTube or Patreon. Thank you so much. How did the development look like then?
It was tough. So back then, you had to record your program to an analog tape. And that process would take 2 or 3 minutes. So you do some work, and test out the game, then save your state down to the tape. And the big downside was, if the game crashed while you were testing it, you lost it. So every time you were iterating, you were kind of gambling on how confident am I that this is going to be fine? Yeah, I'm sure it'll be fine. Or am I going to wait that 2 or 3 minutes to go and record it to tape so I have a backup? It was a very slow iteration process.
That's hardcore development. Like, if you were to apply this to today, it's like, are you sure you want to hit compile? Because you
Yeah.
might want to miss all of your work.
Yes, absolutely. And so then things got better with the Commodore 64. Dean then had he invested in a floppy disk drive. But even then, I remember he was working on a game. He did a game called Druid for the Commodore 64, and then moved on to another game called Cloud Kingdoms. At this point, we were living in Gibraltar. So my father was in the Navy, and Dean and I moved to Gibraltar and lived there for 4 or 5 years. I have a strong memory of when I was around 13, Dean was working on Cloud Kingdoms, and his floppy disk drive had crashed, and he had written corrupt data to his disk, and that was his only copy of the game. The only other copy he had, when it was all written in assembler as well, the only other copy he had was a printout that he had happened to print out in order to go and debug his code 2 weeks ago. So he had this, he had like this 400-page printout of the game, which, having then lost everything, he just then had to go and manually go and retype in this giant printout. It was not fun.
How much time did it take to type that in?
Oh, I think he got it back. I think he worked super. He was quite distressed, so I think he worked obsessively for 2 or 3 days to go and get it all back in again.
Okay, wow, nice. So you worked together with Dean, and this is how you got into like game development in general. And at some point, like, you decided that you want to pursue it as a career, or
Yes.
okay,
Yes. So yeah, I think Gibraltar was a very funny place. It was a very isolated and strange community, particularly for if you were really super into video games. Yeah, everybody else was out enjoying the sun and beaches. I was inside with Dean playing games. One of the other aspects of Gibraltar is that the TV channel only ran from 5 p.m. until about 9 p.m. The only English-speaking TV channel. Apart from on Wednesdays when it was casino nights, because there's a casino and they broadcast live from the casino. And the TV programs I remember watching were The Storyteller, LA Law, and America's Top 10 with Casey Kasem. And there was genuinely a period when I was living in Gibraltar where I was convinced I was going to be a lawyer, because I just been this is the only TV I was consuming. I was going to, I've got to be a lawyer. Fine, that's what you're. Either you're in kind of medieval Grimm's fairy tales, or you're a lawyer. Those are the only 2 options. And so I considered being a lawyer, but then the wonder and beauty of being able to create simulated environments and step into them, I think just carried me through. And the idea of being able to create and code like alternative worlds, Dungeon Master and Oids were just such a huge influence for me. With Dungeon Master, being able to play that game and just inhabit this alternate world just completely changed my life and my view of what I wanted to do.
So the primary thing would be this like creative force, and then the code would be the thing that you have to do, or is it like code you actually liked?
Absolutely, yes. I think absolutely right. In my experience, you can generally look at games coders a kind of on a spectrum of means to an end coders, and the code is the end. And there's kind of like a spectrum between the two. And Dene is fully at it's a means to an end. I'm kind of in the middle where I want the code to be good as well.
Okay. How did then the first professional employment look like for the game situation?
Yes, so I came back from Gibraltar with Dene, and I went to university I went to university, and I was going to be going for 3 to 4 years. The university I was going to had an employment program where you could get kind of an internship 6 months in, I think, into the first year. So it was very vocational focused. I wrote off to Bullfrog Productions to go and have my internship there, and was interviewed and was very fortunate to think and get a job. I was meant to only be there for like 3 to 6 months just to go and do this kind of 3 to 6 month internship. But then at the end of that, Peter said, well, you could go back to university, or do you want to do Dungeon Keeper? I'm what? The only reason I'm at university is to learn the skills in order to do this. And at the time, it was a big decision because, from my parents' point of view, going to university was nobody in my family had been to university yet. I was the first person going to university. And so for my family, it was like a big thing of, he's turning into a dropout. But yeah, never regretted it, and jumped into Dungeon Keeper and Magic Carpet, and was then at Bullfrog for the next 3 years.
So you are officially a dropout.
I am officially a dropout, yes.
Yeah, okay.
No, I mean, you joke, but there was while we were doing Dungeon Keeper, there was an interview with Arena magazine, I think it was, and they spent several days coming into Bullfrog and interviewing the people who were making Dungeon Keeper. And back then, the media were not particularly kind to games. It was still a niche hobby from with a very niche, relatively nerdy audience. And it was really cool that we're in this big lifestyle magazine. And then the photographer came, and the photographer then asked us to stand in really weird positions where like all our arms were in front of us, and we're kind of standing in these really awkward positions. Then when we saw the article, they're like, it was kind of just like a takedown piece on nerds. Look at the way they're standing. And the second paragraph was, and university dropout Simon Carter. No, this was a choice. Yeah.
Okay.
But yes, I am officially a dropout, yes.
Okay. That's interesting that you later on joined Google DeepMind, which is like one of the, scientific kind of core thing that people would go and study now to be able to join through like a, either maybe like a PhD first, and then you can enter.
Yes. Yeah, at the time there was a surprising number of people. Martin Bell, who was the lead engine coder on Dungeon Keeper, one of the smartest people I've ever met. He also left uni to go and join the games industry. Just found that coding as a vocation fitted him much better than university. I think there are probably a fair few of people back then who just found this new job open up that universities weren't necessarily really training you right for anyway.
So join Bullfrog. How does it look like?
Bullfrog was amazing. So Bullfrog, I kind of break up into kind of 3 phases. There was the pre-acquisition phase, the post-acquisition phase, and then the post-Peter phase. I joined right at the end of the first phase. So I had grown up on games like Populous and Powermonger. And so I joined just as the Magic Carpet was in its final year, I think. And from my point of view, it was just the perfect, wonderful, so many like-minded people who had played all the same games. I felt like I fitted right in. It was wonderful. And looking back as well on the people who I was working with, I know Mark Healy and Alex Evans, who went on to go and have a wonderful career. You also had Guy Simmons, who went on to go make Startopia. You got Barry Mead, who went on to do The Room with Fireproof. Sean Cooper, who was one of the very early Bullfrog people, he essentially taught me to code, and went on to various great things. Glenn Corpez, who, another one of the smartest people I've ever met, he joined Bullfrog as an artist and ended up being their primary engine coder. Just because he has the kind of mind that can adapt to all these different things. I remember coming in one day and Glenn had been to I can't remember, I think it was a Pixies concert. And he was saying, while I was studying there, I worked out how to get Magic Carpet to do stereoscopic rendering using the stereogram technology. And then the next day he kind of wrote this thing which then turned it into a proper stereogram in real time. Just a crazy smart guy. And then of course Dennis as well was a Bullfrog back then. But yes, just a wonderful creative culture where the general vibe was just trying to make the best things and just make cool stuff that people would enjoy. Also, in hindsight, it was very board games focused, and I think I only realized that later. So all the games that Bullfrog made were initially, apart from maybe Flood and possibly Syndicate, but Magic Carpet, Theme Park, Dungeon Keeper, they were all initially built as multiplayer games, and so they could only be played by competing against somebody else. So in the evenings, after everybody been coding, my first 6 months though was that everybody's down tools. We're all playing Magic Carpet now. Let's go and have an 8-player game of Magic Carpet, because this is the only way we can work out if the gameplay was balanced and thing. And even like the coordinate system that the games used, most games use Z in or Z up, and at Bullfrog it was X, Y, and then Z is up and down, which is a very unusual coordinate system, and I only realized it was unusual when I left Bullfrog and nobody else used it, apart from maybe Unreal, I don't know. But yeah, it's a very board games kind of multiplayer, top-down units moving around. Up and down is a kind of an optional parameter.
Yeah, okay. It's you said something like that the core philosophy would be like make cool things, and I feel like now game dev as an industry gravitated towards more like a product oriented. Like sure. There's a strong economic focus, and like there's huge budgets going in, and then it's the risk is trying to be like minimized. Is there you think right now a place for a company that would have this as a core philosophy and make games, or is it a product of the past?
That's a good question. Honestly, I think the indie game dev community is where most of that experimentation happens now. I think back then, we were essentially inventing the industry, and the thing that made you sell was usually novelty. It wasn't necessarily quality, and in a lot of cases, I think Bullfrog games weren't necessarily the most polished. They're a bit buggy, but what they did push on was novelty, and then selling at novelty to journalists in order to convince them that this was the next big thing. And Peter was very good at selling that kind of vision to journalists, famously very good at doing that. So I think today a lot of that is now dispersed amongst lots of indies, and we have, in a lot of cases now, flood-filled the possibility space. So risks are, in some cases, less warranted, but risks are, so many of the game ideas have actually already been explored. So people are kind of more naturally risk averse. Back then, I think it was a necessity. Everybody had to be risky in order to sell. I do miss that a lot, though. I do miss the sense that we're all actually trying to just explore and find the best things. But economics.
It had also like this interesting quality that if you're an engineer, you're like exploring new things very often, right? Mm-hmm. Now, if you're an engineer, I feel like you're kind of expected to do samey stuff, because it's like a production, more like less like an exploration, right?
Yes, I think that's very true. And also coming back to your earlier point around means to an end for coding, most of the people who coded at Bullfrog, there was no distinction between artist, designer, coder. I mentioned Glenn. He was an artist and he was a coder. Peter was a designer and a coder. I was a designer and a coder. Dene was a designer and a coder. Everybody kind of wore multiple hats and was kind of wearing whatever hats they needed in order to make the game progress. There were very few full-time dedicated only programmers, particularly in the early Bullfrog days.
How did like the work got organized then? Like I talked to Mark and I was trying to like get from him like how did you work? Like I am so much more in this like, okay, he's like, you do this, you do that, there's a leader, and he's just like, oh, just play games and we found out what's fun and like we did that, and I'm like, this sounds like chaos, you know, like this sounds like everybody's doing their own thing. Like how did it work?
Oh no, it was chaos. I mean, that's why Dungeon Keeper took 4 years. There were so many ideas that we just had to go at and then threw away in Dungeon Keeper. It was total chaos. With Dungeon Keeper in particular, as an example of how chaotic it was, for a good 6 months, we didn't even have source control. For about 6 months, so with Dungeon Keeper, we started building Dungeon Keeper in the main Bullfrog office. And then after a year or a year and a half, we then retreated to Peter's house to kind of reboot it for various reasons. And then about another year in, we then went back to another building near the main Bullfrog office, but that office had no internet connection and no server. So what we used to do for about 6 months working on Dungeon Keeper was everybody would do their daily work from 10 until 6, 10 until 7. And then my job, they would mark up all of their changes by hand. They would then send me their files. I would then hand merge everybody's changes into the main source tree, make sure it compiled, make sure it built, and then we'd play the game for a bit. And that was our iterative cycle. So yes, it was complete chaos, but mostly carried through by people who were passionate and cared about what they were doing enough to get over the enormous friction of chaos and poor planning.
Do we have something to discuss regarding the magic carpet, or should we go directly to Dungeon Keeper regarding like the technology?
With Magic Carpet, my main the work I mostly did on Magic Carpet was the AI system, which was and Sean Cooper teaching me how to code. The main thing I remember from Magic Carpet and my contribution was that it shipped. It shipped with broken AI. The enemy carpet Magic Carpet Flare would just continually use his speed up spell all the time, and I don't know how that slipped through. And so it then had like a day one patch, but back in those days, day one patches were really hard to do. So yeah, my main memory of Magic Carpet is just abject failure for releasing a very buggy AI system. But yeah.
When you say you were you learned how to code, you already have programmed in assembly, right? So when you say you learned, what do you mean exactly?
So by that, I had actually when I joined Bullfrog, I only knew C and STOS, which was the a variant of BASIC that you could run on the Atari ST. So I knew C relatively well. Bullfrog was a C shop, so that worked well. What I learned from Sean Cooper was mostly how to structure a game. So within Bullfrog, the things that I still do today, you have what they called things. Every entity in the game was called a thing. You had the Map-Who system, which was a grid-based spatial partitioning system, so you could quickly look up where entities were. There was the kind of the core update loop. There was how the state machines that you used for AI. It was all that kind of very game-specific stuff that at the time you couldn't learn anywhere else because there wasn't the internet to learn it from other people. So I was learning it from John Cooper.
Okay. And it was all in C.
Yes, all Bullfrog games were in pure C. Certainly up until Dungeon Keeper. It was their weird hybridized version of C, though. Peter didn't like header files, so they had this tool which scanned all of your C code and extracted all function definitions automatically into one giant header file, so that Peter wouldn't have to write it twice. It was a weirdly munged version of C.
Okay. I'm assuming you also had like a Bullfrog base layer for all sorts of like base functionalities, like string related stuff. And
yes, there was also there was the Bullfrog core libraries. Yes.
Okay. And then like developers coming in needed to learn this.
Yes, they did. There wasn't a lot of it.
Okay.
Most games ended up forking that base layer. So, as an example, the engine that Bullfrog used for most of the games post Magic Carpet was Glenn's Magic Carpet engine. But he then kind of, again, we didn't really use source control. He would then fork it, and he added cubes to it, and inverted the height field to then go and draw a ceiling. That then became the Dungeon Keeper engine. High Octane was the same engine, and we took the block thing to go and do the track, and use that. And Dungeon Keeper 2 used the same engine. So it was all just kind of forks of the same engine, and everybody ended up with a different variant of the Bullfrog core libraries, which we sometimes then hand merged.
Again,
I wouldn't recommend it as a system.
Again, like on the one hand, it feels like total chaos. Like it sounds like, nobody has any idea what is happening, because things are being like forked left and right, and like, oh yeah, I use this function, like, oh, I thought it was doing this because on this project it was doing that, but in the meantime, like, somebody changed it. At the same time, maybe like the solutions that we have today that are super nice and sophisticated introduce so much friction that this dumb version is not that dumb. I
think it's also easier when you're dealing with relatively small teams. So I think Dungeon Keeper, for a good chunk of its time, was me, Mark Healy, and Jonty Barnes. So it was just the three of us. So we could move very quickly. And it was only later on that we moved to, I think, around 6 people, with Dene and Alex Peters and Martin Bell joining the team. So yeah, because you're quite small, you just talk, and you can move super quickly. And I think the hand merging of source files only really worked because we were all working on completely disparate elements. I would be working on the AI system, Jonty would be working on some of the rendering systems, and we didn't really overlap. So it kind of worked neatly.
Okay.
So yeah, and so I guess chaos is more manageable when you're sub 6 people.
Yeah. Then Dungeon Keeper was like the first full production that you've worked through in Bullfrog. How did it look like? What did it look like from your end? What did you worked on, and how did it then what the production looked like?
So Dungeon Keeper was so as the technical lead, an awful lot of the code in Dungeon Keeper was touched by me at some point. It was a pure C code base. It was like all Bullfrog games at the time. It was deterministic multiplayer. So everything moved at a fixed time step, and we would then go and send out the update packets to other multiplayer systems. They would then come back, and everything was in lockstep, which created. There were so many problems in Bullfrog games around maintaining determinism, because it had to be a deterministic game. So trying to maintain your random seeds and making sure that your particle system didn't break your core rendering your main game seed. I remember putting in logging in the particle system, which would turn off particles if they were not on screen, which then broke determinism because the particle system used the same random seed as the main game. So then we had to go and bifurcate the seeds, and okay, learning as you go. And then the main game was then just pure vanilla C. All of the AI was a giant state machine table, which put me off doing state machines pretty much for every game since. We invented a completely different system for Fable just to avoid doing Dungeon Keeper style state machines. The reason it was terrible was that you'd have all creatures would have their desires and what they wanted, so hunger level, fear, how tired they were, etc. So those things would be states, but then they would call out to functions that would need to run over multiple turns, like navigation. So you would have being hungry, which would then need to push you into the state of walking, which would then, when you'd reach your destination, would then pop that state off the stack, and then you'd then go back into being afraid again. And now I'm near where I need to be. Let me work out what I need to do next, and put in the next thing. And this mixture of states that were actually behaviors versus states that were decision points made it really hard to wrangle the code, because you end up them having to bodge. I've got to the point where I'm going to, and like now, actually I'm not going to pop back to being scared because something is interrupting. The keeper has just slapped me. I've now gone pop that out and then go into a completely different state table. And you ended up with this spaghetti joining up the state table, looking like a 1920s phone operator, and of trying to plug all these things together. And debugging it was just, why has the imp now decided to go into a oh no, we have no way of debugging this. Yes, awful. So yes, regretted that and decided never to do state machine again, because it was just a really bad state machine. Then
on the state machine,
yeah,
because there's like in the game AI, there's this concept like goal-oriented behavior, where
yes, it was very much like that.
So could this model like work? Like, do you see it working if you change and adapt some of the things? Like, what would you avoid, or is it just like a broken model?
No, I think there are definitely better ways of handling it. The way we ended up handling it for Fable, for example, is by using cooperative multitasking. So essentially, the thing I just described, where you have this thing here, it then goes and wants to do a thing, and then you then have another decision point over here, fits very nicely as a coroutine, which you then suspend the stack, go in here, I'm now navigating, suspend the stack, wait till I'm there, and then make a decision point later on. Fits much more neatly into that kind of archetype. And that's what we ended up using for Fable 1. We ended up kind of inventing our own stack saving code so that we could follow that kind of path. I think there are much better ways of doing state machines today, though. Don't ask me, because I'm clearly terrible at writing state machines.
Okay.
I guess the other really big thing in Dungeon Keeper, which almost completely changed the direction of the whole game, was the navigation system. Because we were building this complex dungeon which you were modifying in real time, and we had all of these creatures, all Bullfrog games up until then had just used very simple wall hugging techniques for navigation. So if you're familiar with wall hugging navigation, you plop down, you navigate until you hit a wall, and then you stick your hand out and just follow the left hand until... Yeah. And it's a good standard maze solving algorithm. And then if you see your target point, you then shortcut that and do a line of sight to your target point instead. Most Bullfrog games just use that, and you ended up with problems in things like Populous, where you could get the characters spinning on the spot because they go, I've got nothing to hug. And that was why. Because we had so many creatures and we wanted them to behave intelligently, we were determined to have a really cool navigation system. And a chap called Ian Shaw wrote this incredibly clever Delaunay triangulation system for the maps, where you would turn the map into essentially a nice set of triangles, and then do something like A* through the barycentric coordinates of the triangles. The big downside to it was that it took about 400 milliseconds to update, which for a game which is about construction was a real challenge. And so we ended up, the game initially, in order to avoid these very expensive navigation updates, was much more build your base, and then enemies will come into your base and you can't modify the base anymore. It was much more like a kind of a Command and Conquer style game, entirely because we were trying to avoid these navigation updates. And then two things then happened. One, Peter kind of came back after having been absent for a year or so, and kind of went, hey, this isn't the game I was thinking of initially. Can we revisit it? But then also crucially, Ian worked out how to do partial updates on the navigation, which got rid of the expensive 400 millisecond update and turned it into something that we could just incorporate into a general update, and that completely changed the course of the game, being able to do that.
Okay, it's very interesting, like how both like technical things and then like, or let's say design feedback heard late in the process can adapt the entire game.
Yes, absolutely.
Was it if you have, for example, if you were to write this system now, for example, right, and would you now try to be like back of the napkin, calculate what's the performance of it, or you would just like try it and see how it works, and like what would be the strategy?
I think now what I would do is, one of the challenges we had at the time was that so Dungeon Keeper was in development for 4 years. Peter was promising it would be out in 3 months at all points during those 4 years. So we were continually under the kind of the cosh of, we need to be shipping this in 3 months. We don't have time to revisit anything. Let's just keep going. There is this problem. We need to keep moving forward. So we need to be shipping in 3 months. So it was only when we then kind of had that reset, where we then had permission, essentially, to go and take a bit more time over it, that we had the space to reevaluate where we were and look back at the approaches we were taking. What I would actually do, though, now with the benefit experience, is, what is the game we're trying to make? The game we're trying to make is meant to be about you being a dungeon keeper and having this simulation which you're interacting with. A thing which makes that your interactions with that simulation a pause for 400 milliseconds is just not going to fly. If we're going to have slightly crappier AI in order to give you the experience we originally intended, that tech just needs to go, and we'll just go back to the old ways. That's what I should have done in hindsight. Try, and even experimenting with things and trying things out and going, this just isn't going to fit. That's fine. That's the only way that innovation works. And you trust people's gut instincts around how long things will take, because they usually experience and they know how long it will take. But you try things, and you just need to have the courage to then go, this isn't the right thing for what we're doing. Alas, we're going to have to lose it.
How much of the code you wrote for Dungeon Keeper got canned this way?
Oh, it's very hard to say. Because all of it was in there somewhere at some point. We never deleted code because we had no source control. You
just stopped calling the function. Like, you stopped calling the function.
Stopped, exactly that. It was just, you just stopped calling it. We had lots of features that were half written and dropped. I think the biggest one, the two biggest ones from my memory were, I think 2 weeks before we shipped, Peter decided that he wanted a new room to be added to the game, which was a casino, which the creatures would all go to. And we started writing it, and then we're 2 weeks away from burning the CDs, God. So we abandoned that. But a feature that we did have that we then did drop was, again, it was another one of Peter's late night flights of fancy. He wanted it so that if you were playing the game post 8 p.m. in an office with a printer, the enemy heroes coming into a dungeon would print out threatening messages on your local printer.
What?
So you'd be playing Dungeon Keeper, and you get, what's that? And you go, it's a message from the heroes. They're coming to get me. And on paper, it was a great idea. But then you just forget that people are playing these games in just shared offices and things, and weird messages are coming out. And like QA were playing the game and going, we've got 50 pages of threatening messages from the heroes. What are you thinking about? So yes, EA made us can that feature, in my opinion, correctly.
There's this style of games that do like mess with your file system now. But like, ideally you should, before getting into that game, that like things can go like for example, there are people like streaming the game, and they see, for example, the file path inside the game from their disk. It's like, wait, what is happening? So that's
no.
but this gives me these vibes, like,
Yes.
what's happening with my printer? I didn't ask it to do anything.
Yes, I increasingly firmly believe that computer games and viruses should be different things.
Yeah, nice. And Dungeon Keeper, in terms of like release, you said, because you're saying like 4 years development cycle, like back then this was a humongous length, like this, just the duration was out of this world. And you said Peter promised like 3 months throughout the entire development. How did the actual shipping went? Like, you needed to burn the CDs, which is different than what you do now. So you need to have like a physical thing. You then like you kiss it, say bye-bye. It's like, it's gone. Like, it's out there. You cannot really change it. You mentioned like day one patch. I have no idea what does it mean in the CD area.
Yeah.
How did it look like?
So the all of the CDs were burnt by me, not the ones in the shops, obviously, but the master CDs of Dungeon Keeper. The way it worked was you would post them, or you'd send a courier to EA head office. So I would. Bullfrog had one single disc at a time, and I think maybe 2x CD burner. And the shipping process was me. At 11 o'clock at night, literally using a bit of CD burning software to go and put it onto the CD, burn it, wait for half an hour, test that CD while the next one was burning, and then do that for 3 hours, and then go and send out the CDs to EA. We had one situation at Bullfrog where they were so all of the final master CD was like the one that I hand burnt and sent off to EA. Then we had one situation where a game, I can't actually remember if it was Dungeon Keeper or another Bullfrog game, but we discovered a fatal bug on the version that had been shipped to EA, and they were about to start manufacturing it in the US. And so we had a member of staff literally get onto a plane with a CD with the bug fix, fly to the US, hand it over to a person at the airport, and then just fly back later on that day in order to be able to press the CDs in 24 hours. It's very silly. Launch them went very well. I remember we had journalists coming in playing the game, and we had the first journalist I remember coming in clearly loved it, and the sense of relief after 4 years having somebody external come in, and you lose all perspective after 4 years, and you've been working on it, and you're aware of both the superposition of the features you're shipping and the features you've dropped. And you completely lose perspective of the bit that you actually are giving out. You completely lose that perspective. So you kind of end up going, this could be amazing or it could be shit. I have zero perspective. So the idea that somebody's playing it and really liked it was wonderful. I had a full thick head of hair at that point. 6 months prior, I had then lost most of my hair during Dungeon Keeper. And then, so we shipped it, reviewed well. We then discovered a fatal bug where the enemy Dungeon Keeper on level 4 would just break. He would stop working. He would do nothing. And he would then do nothing on most subsequent levels.
Because of AI system?
Because of the AI system. And the AI, I mentioned earlier that most Bullfrog games and Dungeon Keeper were built primarily as multiplayer games, and then you crammed in the AI to then go and replicate a human playing the game later on. That bit of code was Peter's. Just putting out. The AI system was written by Peter in very rapidly over the last 2 or 3 months of the game, and it seemed to be fine. And then we shipped the game, we realized that it was fundamentally broken, and then me, Alex Peters, and John T. Barnes the next weekend we're then ripping it all out, rewriting it from scratch. I don't know if Peter actually knows that we've completely rewrote his AI system. And then we shipped that out as a day one patch, which I think had to go out on. I think I may have had to go out on floppy disks at the time, but you may have been able to grab it from the internet as well. But yes, there's like a Dungeon Keeper 1.1 which had to go out to go and fix this fatal bug.
But it
Yes.
dates. It shows like how recently I was born. But day one patch in this moment of time looked like you have a CD with like a full game, and then there's like a floppy, or like. And where do you get the floppy from? Because I bought it CD in the store, and then how do I get the floppy?
So I believe at the time you would magazines would come with floppies, and they would sometimes have the patches for various games on them, amongst other things. So you could go and buy a magazine and have the floppy disk, and I think you could then, if you had the internet and you were futuristic, you could probably download it, and then I think then the second pressing they then embedded the patch into the CDs. So it was only the poor unfortunates who bought literally in the first month or two.
The early accessors. When you said, by the way, when you said that like game journalists came and it was a sense of relief to see them enjoying the game, what about like testers, external testers? Did this happen, or there was no time because there was a development happening? Like,
no. We had internal testers. We had a really good team of internal testers at Bullfrog, and they were the people we usually relied on to see if they were enjoying the game. And also we had a really good kind of internship program where we would get people who were interested in joining the industry. They would come in through testing, and so we get some like summer students, interns, and things, and a good turnover of people like that who were playing the games and would give us continual feedback. So that gave us some degree of perspective, but they weren't seasoned, experienced people, and getting somebody who was completely objective, giving you positive feedback was very rewarding. Okay. It was the Bullfrog's approach to having young, fresh eyes continually coming in to play games. I think that was actually one of its bits of secret sauce, because it did give you this continual feedback of whether or not people were. It was kind of like an early version of releasing early and often and getting feedback from your audience.
Okay. Is this then where we close the Dungeon Keeper and we move on to Fable?
Yes.
Dungeon Keeper was released as Bullfrog, and Fable was released as by Lionhead, right? So
yes,
there was
that's right.
A little bit of like game studio shenanigans that happened in the meantime. Yes. Can we talk a little bit about that so that everybody?
Yeah, sure. So Peter left Bullfrog in '97, I think, just after Dungeon Keeper, and set up Lionhead and took a bunch of people from Bullfrog with him. Dene and I, at this point, had always wanted to have our own game studio, and we were working out what our next step was going to be along that front. So we were working on a few prototypes for Electronic Arts, because Bullfrog was now owned by Electronic Arts, while working out what we wanted to do next. So we were pulling together a small team. I was still in contact with Peter. I was because Dungeon Keeper had been so intense. I had lived in Peter's house for the last 3 years of that, and I was still living in Peter's house. And so I was going to say, Peter, Dene and I are going to start up this company. Are you interested in getting any help? And he then set up the Lionhead satellite system, where Lionhead would essentially give services for putting into contact with publishers and helping with design advice and things like that for new companies. And we were the first satellite studio that Lionhead then invested in. So Peter didn't really own Big Blue Box, which is the company that Dene and I ended up making. Dene and I got the experience of setting up this company all by ourselves, but we had in the background, there was an adult in the room who'd done this before.
Big brother, yeah.
Exactly. who could give advice and or shake their head if we were making very poor decisions. And so then Fable 1 was mostly a Big Blue Box game. We were then acquired by Lionhead in the last 18 months of Fable 1's development, which is why the Fable 1 intro has the Big Blue Box logo and then the Lionhead logo. And then Fable 2 is just the Lionhead logo.
Okay. Can you tell me a bit about like pre-production process, the exploration for Fable? Like where did the idea come from? How did it start?
So Fable was not the game that we started making when we started with Big Blue Box. Fable was, when we started with Big Blue Box, we sat down and we were thinking through games that we thought would be popular and commercially viable. And I think we were discussing earlier on that the way to sell things back then was to take a concept and then innovate on it so that you then got some journalistic momentum, and then you then got it was the way to kind of go viral back then. So the games we were inspired by at the time, Dene and I loved Chaos by Julian Gollop. That was a huge inspiration for us. And I had obviously worked on Magic Carpet, and what we wanted to do was merge the two concepts so that you could you could summon creatures, you could kind of do this real-time, almost kind of Command and Conquer-ish combat, but through a Magic Carpet-like avatar who was running around on a landscape. And the idea was that you were kind of these gods who could like rip up bits of terrain, throw them at each other, summon armies of creatures, grow huge forests, build your own castle, which would then be the place where you'd inhabit. And it's a kind of grandiose power mongery, Magic Carpety wizard battling game. That's what we were working on for the first year. I've recently written about this. We then pitched this to a number of different publishers, and there was one publisher in particular who was super interested, and they're really enthusiastic. And we kept on going to them with like more and more information. The audience of the people from the publisher got bigger and bigger. I think at the end there were like 10 people from the publisher, and we're thinking, this is going really well. It's great. And then they just stopped talking to us. And then 6 months later, this publisher then pushed out the first preview of their game called Sacrifice, which is a very similar concept to what we were pushing with Wishwand. I very much doubt there was anything particularly dodgy going on there, but it did, because innovation was such an important part of going viral, our novelty factor had disappeared. So at that point we then pivoted to think about what else we could do with this technology that we had built, which was then eventually Fable. So I mentioned earlier on that growing up in Gibraltar, The Storyteller was one of the things that we watched endlessly. And then growing up on games like SimCity, Populous, the idea that had grown in Dene's and my mind was essentially being able to run a simulated world where you could go on role-playing game adventures. These days, not in any way innovative, or it's so obvious and commonplace. But at the time for us, this was like the most exciting concept ever. You could live in this world. You could choose to go and raid a dungeon, or you could go fishing. That could be entirely your choice. And it was just like, in a world that is so alive that fishing would just be a natural fallout of this simulation. And then the storyteller component was the visual element that then kind of bound it together, where it was this dark Grimm's fairy tale world where folk tales were real. Magic existed, but it was mostly a source of gossip and suspicion, and people wanted to keep to their cozy villages and keep away from the dangerous magical darkness at the edges of their villages. We loved that kind of cozy, threatening, magical feel, and so the combination was very obvious for us. And so at that point, we had the Wishworld engine, which was essentially designed for multiplayer. It was the deterministic multiplayer height field game with a deforming landscape, and we then tried to shoehorn that into this new concept. And for about half of Fable, all of the terrain was completely deformable at runtime, completely pointlessly because you never needed to do it. But it's just the pre-existing code was there for that.
How was you needed to fold back the tech that was underlying, that was developed in mind for a particularly different game. Was this, you then, I can imagine starting a new fresh and just ripping up the parts that you needed and build something that you wanted, or you just say YOLO, code means to an end, we start here, we continue. What's the strategy?
From our discussion so far, which one do you think we picked?
I think the latter one.
We've very much picked the other one. We very much YOLO'd it. So I was mentioning earlier as well that Dungeon Keeper, well, this is also partly because it was the way I was taught to make games. Deterministic fixed rate frame rates. Fable 1, its internal frame rate, Fable 1 was a deterministic multiplayer game at its core. We only dropped the determinism element relatively late on, but it also meant that it was also a lockstep game at its core. So the internals of Fable 1, the game ran at 15 frames a second. The renderer ran as fast as it wanted, and it would then just interpolate between the frames. So in order for that to work, it meant the renderer was actually rendering between the previous game state and the current game state. And that if you then ran over because it was running too slow, it would then forward predict. But what that meant was that the renderer was always 2 frames behind because it was only interpolating up to the current frame. And so the input latency on Fable was crazy. It was something like 200 milliseconds because between the input coming in, rendering the 15 FPS, and then the renderer then running at 30 FPS and interpolating, it was just such huge input latency, which back then you didn't notice too much, but in hindsight was very much an artifact of us YOLOing it and going, well, we've got this engine. Let's just keep going with what we've got. That's how you make games, isn't it? Yeah. Yes, really. I do regret that. I should have thought of that more. One of the big changes we did make, though, was the bullfrog method for entities was, although it was mostly C, it was you had a thing, and then you essentially inherited off that thing, which is your entity. And you monolithically just kind of added more and more behavior to it. For a role-playing game, that was just getting increasingly hard with Fable. Because the classic problems of inheritance, where this creatures need to have an inventory, so therefore we now we put inventories into creatures. Oh, now we have a chest. This also needs to have an inventory. Let's make inventories creatures, I guess. That's the only way of doing it. And we were falling down that rabbit hole quite quickly. I then went to a GDC in, must have been 1999, 2000, where Scott Byleth was talking about the system they used on Dungeon Siege, which was the first time I'd ever heard of component systems. And it wasn't a full ECS system. It was much more Unity-like, but it was. He was talking about using templates, the definition language that they used, and I was sitting in the audience going, "This is just the perfect fit for this giant role-playing game that we're making." And I literally then flew back and then just converted the entire game code base over to entity components with this wonderful definition language where you would describe in text that you had a creature, you would give it its various components, and you would define in text what its various property values were, and they would be inherited. It was an inherited, much like inherited prefabs today, where you'd say, yes, a creature comes off the base object, a base object comes off thing, and then for this particular monster, it inherits off creature, and therefore has these extra properties. And it was a fully componentized system. one of the best decisions we ever made for Fable, having this wonderful text definition language, this very modular component system, way before most other games. Most other games were still using inheritance, and it just made life so much easier.
So you had text files like config files for entities with properties. Did you have like hot reloading, meaning you could change?
No, very much not.
Okay.
No.
Okay. So this, wouldn't it pose some problems that like you have this text file? Because normally engineers are happy to be like in the typed system where like type are being checked so that like compiler helps you. Here you're like, okay, stepping outside into the text file, like where none of these applies. Like, was this problematic at some point? Like, or is it just like this decision was like the best and drove the entire project, or were there some downsides?
That's a good question. So you mean in terms of things like LSPs and autocompletion and syntax coloring and things like that? Back then, autocompletion and IntelliSense in Visual Studio was relatively new. We'd only been for Dungeon Keeper. I don't think we had syntax coloring at all, and no autocompletion. So that was all run the compiler and see what it tells you each time. In hindsight, yes, that seems like an obvious omission. At the time, I don't think we really felt it. The alternative was to use C++ tables and have compiler link time issues. And all of these variables, I think we had an in-game console as well. So you could do your balancing from the in-game console where you'd type in stuff and modify values directly. And then, yes, I went and set the goblin's health to 17. Let me go and put that back into the text file.
Okay.
But no, yeah, in hindsight, like an LSP of some sort would have made life so much easier.
So through in-game console, you had a bit more room to like prototype some of these properties for these systems, and then the text files were the thing that just was persistent across the runs, so you could have
exactly that.
Okay, nice. And for the design of Fable, when I played it, like the big component for me was the morality system. Was this like a huge big thing in terms of the design? Because like it opens like you are this kid and you can do the bad thing, but you can do the good thing, or you can do both one after another, you know. So was this, how did it influence the development both on the design and then in the programming side?
In terms of how that kind of came about, it was very natural because, again, in Bullfrog games, there was always this balance of trying to give the player enough freedom to express themselves in whatever way they wish. I think that the tagline of Dungeon Keeper was, "It's good to be bad," which upset a number of Americans at the time. And then at the time also you had Peter, who was working on Black and White, which is obviously all about morality. And so kind of the background for the simulation space that we were inhabiting was that morality had to be a feature. It was a key way of the player being able to express themselves. In terms of how it affected programming, the main thing was, I guess it was less impactful than you might think, because in the background to all of Fable anyway, we did have this complex simulation system built with a goal-oriented AI system where various stats and things were changing continually. So the same simulation system, villagers, for example, in their AI priorities would have, am I afraid? Am I hungry? Have I done my job? Have I been to sleep yet? What time is it? And they'd have these kind of lists of priorities. They would be fuzzily, probabilistically chosen between. And so, for example, if you wandered into a village and kind of raised your sword, that would increase fear in the area around you. And then the simulation system would then just naturally propagate that. The AIs would then naturally go, I am now afraid. There is a threat near me. I'm now going to go and trigger my flee. And the flee behavior would then take them home, etc. layering morality, it was just another simulation variable. Whether you were evil, whether you looked magical, and we just kind of laid that into the general simulation interpretability. So that bit was relatively easy because it was kind of the fabric of what we were doing anyway. The main challenge there with the simulation system was content. When you're making a simulation game that is 2D and top down, something like Theme Park, that simulation layer, you can represent what people are feeling, what people are doing relatively easily with icons above their heads. And they can still be playing the same walking animation, but you now know that they are sad. When you had doing it in a 3D AAA full-on game, trying to represent their emotional state, that required assets and animation. We had to go and have run animations for all the people who were doing menial jobs in their houses. We had to have brush animations. I don't know how many people actually ended up seeing this, but all of the characters had full going into bed, pulling sheets over themselves, lying in bed, sleeping animations, getting up in the morning and they had all these cycles, which you usually didn't see because the doors were locked, and breaking into a house would trigger a crime. So most people didn't do it. But all this content was created for it. And again, in terms of planning, that's one of the areas where we probably could have saved a lot of work, but if we had actually planned up front, what can people see and what can't they see? But yeah, we had animations and state transitions and so many visualizations for things because the simulation demanded it. We never really checked to see whether or not people would actually see it. And then the other bit of the morality bit was in the hero morphing, which was a huge piece of work. That was all done mostly through bone morphing, so lots of bones around the hero's head, which would then expand out, bones around his stomach, bones around his arms. And then every time you changed level, we had a texture morphing system, which was essentially like Photoshop layers, where you'd have the base hero face, you'd have his various evil morphs for textures, you'd have various magical morphs, and then every time you changed level, we would use that the loading time to then cover up 100 milliseconds or so of laying out, dynamically generating some of these textures and then putting them back on your face or whatever. So a combination of those things was how most of that was done. Oh, in a very complex clothing system as well, where you'd have to go and mark up the hero so that when you put on gloves, we then knew which bits of the hand to remove so that we wouldn't have the rendering cost. And so, like a really complicated masking system for what bits, each bit of clothing would then go and block off so that we wouldn't then going to have to render it and stuff like that. So, yes.
Yeah, and like particle systems, because like when the hero walked, like it had the
flies.
smoke and like everything, like all the flies and like
yes.
Yes. I like remember like this was such a magical feeling to have your hero changed based on the morality. When I played this as a kid, this was so good. Like this influenced so much of like my then later preference for like RPG style games.
Really?
Because of this, like, oh, I could be bad, I could be good, I have these spells that are different depending on where I'm good or bad. I can do this, I can do that. I can try to be sneaky and like do both sometimes. And it's like these like questions like why should I do that, or what should I do like within the entire game that has a storyline. This is so cool.
Yes. Yeah, that's wonderful to hear. And that was exactly the thing that we were going for, was this sense of me as a player. I want to inhabit this environment and I want to be able to express myself in ways that I want to be able to express myself, and then have the world respond to that, and to have both the simulation and also how I am represented on screen respond to that. So it's wonderful to hear that came through for you.
The simulation, in terms of like technicalities, you mentioned like coroutines and as a implementation method. At the same time, like if I think about how many things are simulated at the same time, that's such a combinatorial explosion to test all of these things. Like how what is the approach there? Like you couldn't have possibly went through all of this cases of everybody like trying to see what happens in all cases. So do you have some sort of testing tools trying to run through the simulation as fast as possible, see where it ends up, like fastest?
We did have testing tools that allowed you to trigger the various events. Most of the AIs tended to work individually. So it was fairly carefully designed to limit overlapping opportunities as much as possible. So most people knew where they lived, so when they would flee, they would go back to their own house. People wouldn't need to pair up too much, so they didn't have to overlap in terms of what they did, etc. One of the things that Microsoft were enormously helpful throughout Fable 1, and one of the things that they brought from their OS testing department was the idea of SDETs, which were software developer engineering testers, I think. And they were essentially coders, but who did QA. And they did so much automation for Fable. We exposed lots of hooks for them to be able to trigger various events. And then they went and built scripts, which then triggered various things. And they just used that to go and find bugs, crash bugs, issues, deadlocks, automatically. And yeah, that was a really big part of what allowed us to manage the combinatorial complexity that having a relatively floppy simulation enabled. Yeah.
What are the other cool systems in Fable that you want to highlight from the technical side?
Yeah, so there's a few things. So that cooperative multi-threading system that I mentioned, it was all handwritten, but we used it for loads of things. That was what allowed us to have the icons spinning while you're loading because we weren't blocking the main thread. I guess stepping back a second, the Xbox had one core and one thread, so everything was running single-threaded. Okay. So anything that was then essentially animating in the background would be the main routine calling out and updating it within the loop, so you could not block the main loop. So having cooperative multitasking enabling you to do things like spinning icons was super. We also used it for the scripting system. So the scripting language in Fable, we tried various things, including visual scripting. And then I think I just decided they were all shit. And because one of the main things you want from a scripting system is the ability to suspend execution for it to run in the background, essentially. I wrote a macro system for C, which our scripters ended up using. So it was just these kind of lots of things in capital letters where you could go and get an entity, tell it to go and do a thing, wait for an event, all using this cooperative multi-threading system, which compiled into a DLL, and then you then load at runtime in the game. Crazy, but it had the advantage that it was also completely debuggable, didn't need an LSP, and all those other nice things.
Can you say it again? That like the architecture of it? Can you say it
again?
Yeah,
so it was basically it was C functions, and in order to hide the complexity of, it was C and C++. We didn't want our scripters dealing with objects and pointers and things like that because they weren't coders. So they would get handles. You'd have you'd call in capital letters, get player entity. It give you the handle to the player entity. We then had all these other macros, which were essentially our API, which would then call out to like give player weapon in string, and that would then go and call out to the special function we had written on the main code side to then go and do that thing. And we filled in this API side with lots of macros. The macros were essentially hiding all of the pointer complexity and everything else, so that then all the scripters then had to look at was very basic for if, get things, put things, and it was just a very simplified language. And because the game took a fair amount of time to compile, we put this into a DLL so that they could just iterate on it relatively quickly, and their compile times weren't so awful. But then the key bit around the cooperative multi-threading bit was that when you had find Hob go to this target, wait for Hob to get to this target, the script has to wait, which is where the cooperative multi-threading then comes in, where that would then, behind the scenes, pause until we, from the game side, sent the event that Hob has got to where he wants to get to. Then the script resumes and carries on from where it was. And so it kind of magically then handled that behind the scenes.
Nice.
It was kind of nice. It was also just obviously just a massive bodge because we should have used a real script language. But
why didn't you then?
I think at that time there weren't many good scripting languages. There weren't many options. Most games wrote their own scripting language, and I didn't want to still write. As soon as you write a scripting language, you think that you're going to write a debugger for that scripting language. I had seen Black and White. They had their own scripting language for the creature AI. They had difficulty with debugging it. The idea of just being able to all you want scripters is to be able to do these imperative things, and you want a debugger. Let's try that with just macros. It's fine. I guess the other big thing we should touch on probably is is streaming, because the amount of content and features and just stuff in Fable and getting that to fit inside 64 meg of memory. There was in Dungeon Keeper, we had experimented with streaming audio. So most of the audio, the sounds, were loaded on demand, and then we would load variants in the background so that you would always have a sound, but then variants would just kind of come into a cache. In Fable 1, we did that for everything. Everything was streamed in. And we streamed things off both the DVD and the hard disk simultaneously, because we had 2 DMA channels coming in at the same time. So that gave you double the bandwidth. So the terrain would come off the DVD. We put the terrain height field on the edge of the DVD so that you would get maximum throughput. Because the edge of the DVD, you get it's spinning faster because it's a constant angular velocity. So we would be streaming in the terrain from the edge, while we'll then on the main game streaming in textures, meshes, audio, animations, and probably some other things as well from the hard disk on demand. Which is where we dropped determinism, because once you start streaming in animations, your game then becomes non-deterministic because you don't know which animation you're going to get.
I just realized, like, while we were talking, that we should mention the specs that Xbox had, which was the platform for Fable when it was coming out, so that everybody's like up to the speed on the constraints.
So the Xbox One had a single core Pentium 3, I think, running at 700 and something megahertz, 64 meg of memory, and uniquely amongst games consoles at the time, had a 4 or 8 gig hard disk, and each game got a 750 meg partition that they could put stuff on. So when you put Fable into your when you put Fable into the drive, that very long Lionhead Big Blue Box Microsoft logo was there to mask us panically trying to transfer as much data as possible to the hard disk so that we could start then playing the game from the hard disk as quickly as possible, because the game just would not run from the DVD drive by itself because it wasn't fast enough. So we were then fire stuff at the hard disk as quickly as possible. You're then at the menu screen. Make sure you can't get through the menu screen too quickly, because we're still streaming stuff in. And then we managed to get everything in just in time. Microsoft had various TCRs for how long the player was able to wait without interaction. So if we left you at the intro screen, we're just streaming stuff in, then we would fail. So we let you get to the menu screen so that you could interact, but still not actually, you had to go down to go. And we're still streaming, so it gave it an extra few seconds to stream stuff in. And then the amount of we filled that 750 meg partition with stuff. And Fable is an open world game. We didn't know what stuff is going to be used in any level at any given moment. It's also simulated, so you can get people being panicked, and you can get guards appearing. You can get sounds that you weren't expecting occurring at any time. So per level, we didn't know really what you were going to have in that level. So it was all streamed on demand, and piping 750 meg essentially of content through, I think, a 32 meg cache window was very hard. And everything is just moving in the background. Your DVD is spinning, the hard disk spinning, just feeding stuff continually, while we up-res and down-res graphics to go and get everything to fit in. It's crazy. I played the intro parts of Fable 1 off DVD so many times. The last 2 months of Fable, I was just continually playing off the DVD emulator, playing the first 90 minutes of Fable because you could outrun the terrain. You could outrun the terrain but only under circumstances where you were triggering other things to be streaming in. So I would be, all right, okay, I need to now, this particular bit of terrain, I need to go and push out further on the DVD. I need to make sure that I need to go and tweak the cache size for the meshes so that we aren't streaming in too many meshes at the same time, because that's now affecting the terrain, and just continually tweaking the stuff so you couldn't outrun the terrain. It's so crazy.
Wow. There was, I think it was Xbox and generally like Microsoft who standardized that game boot into the menu, right? Like before that, game could launch. So I guess for Fable it was like, oh, that's great. We have a couple of more seconds to actually do
precious seconds to transfer that data. Really. Absolutely.
And
the other weird thing with Fable I've just remembered is because we came from PC development, I did a very bad job with memory management discipline. We had a really good memory allocator in the background, which prevented memory fragmentation and things like that. And Fable fit comfortably within its 64 meg. But over time, even with our very clever memory allocator, you would get fragmentation issues where we would then start to not be able to use all that 64 meg. And that would only occur if you were playing the game for 7 or 8 hours straight and you were triggering lots of very complex things, which then caused memory to fragment. One of the very clever engineers at Microsoft in the last 3 or 4 weeks saved our bacon by putting in a virtual memory system into Fable. And so after 7 or 8 hours, if this fragmentation occurred, it would then page out pages of memory to the hard disk, because there was always a guaranteed hard disk with the Xbox One. And it would page out this memory, and therefore you would get a reduced performance, but it wouldn't actually crash the game. And then I remember, he then ended up running the Xbox emulation department, so that when the Xbox 360 came out, they could be back compatible with the Xbox One. He ended up working in that team. And one of his first jobs was having to convert his own virtual memory system to the Xbox 360, which had no hard disk, or at least it was an optional hard disk.
Oh.
So he had to go and back convert his own horrible code in the last few minutes to then go work on a completely different hardware spec. Yes, he regretted many things.
What a feature to ship in like the last couple of weeks. Like, here's a virtual memory system, like on top of everything. This surely doesn't like cause any trouble, like it touches everything like that. Definitely.
It'll be fine. I think the only reason we were comfortable with it was that it didn't then, we knew that it wouldn't trigger in most cases. It was only going to trigger after in extreme cases. Still deeply embarrassed that we had to ship with a virtual memory system, but anyway.
When you describe like the constraints, hardware constraints of the Xbox platform, and then you mentioned that you started off like as a different game with deformable terrain. What I'm thinking is like I am stressed that the Fable during mid development like takes up too much resources, and there are certain things that just cannot happen. And it blocks like the entire thing, blows up the entire project. what was this a concern? Like, how did you approach this with Dene and other people?
Yeah, I mean, this is a continual concern. And I think this is also the first console game I'd ever worked on. So it was the first fixed platform I'd ever worked on. Coming from, I think when you had, around that era, a lot of the people from Rare, say, had grown up working on fixed platforms for a long time. They had specific ways of working where you'd have your content creators have a fixed budget that they can spend on the terrain. They'll have a fixed budget they can spend on meshes. It is then their job to make sure that things fit within those budgeted resources. And that works brilliantly and is the right way to approach these things. It's really difficult. And because I was coming from PCs, we didn't have those constraints. We didn't tend to focus on those things. We tended instead to focus on making it easy for content creators to make as much content as possible, making it easy to express this complex simulation in readable code. We just had like a different set of priorities. And having to manually manage all of your memory very carefully while you're trying to create this complex simulation AI system. It was a set of problems that you just didn't want to have. Probably should have changed that. But with simulations, though, it is really hard to actually predict what you're going to need and to actually budget things carefully because, in Brightwood, in Fable 1, the resource constraints for that, it is a big area. It's mostly height field, very few buildings, lots of foliage. That's where most of the budget is going. When you go into Bowerstone Village, most of the cost there is actually the navigation system and the density of the rendering of all the buildings, and it's all occlusion culling. The memory constraints for each thing are completely different. The rendering budgets are totally different. The AI and simulation budgets are totally different. And trying to create a budgeting system to go and kind of cover all those things is doable, but it wasn't a thing I'd thought of at the time. So yes, so to answer your question, most of Fable was me being very clenched and trying to make sure things fit. And in fact, for the last 6 to 12 months of Fable 1 was me and a few other people just getting everything to fit. The dev kits we had a bit of extra memory, so we knew nothing was blocking anybody else. We could also run on PCs if you wanted to. So our job was to go and take this game that didn't fit and make sure, optimize, make things smaller, compress, stream something else, and just continue to try and squeeze, while getting very angry with artists who just added another 400 polys to a building or something.
How did the development change? Because it started as you and Dene, and then at some point the team grew. So how did to what size the team grew, and like how did it impact the development?
Yeah, the team changed enormously. So when we were pitching for the first year, it was me, Dene, and Ian Lovett, and then later on Casper, Martin Bell, and one or two other people. So it was like a team of 5 or 6 people. We then grew to about 15 or 16 people once we signed with Microsoft, and stayed like that for the next 2 years or so. And at the time, 15, 16 people making a game, that was the largest team we'd ever worked with. We were sure that would be enough for a complex, content-heavy, simulation-driven RPG. We were absolutely sure. And then after the end of that second year, we go, we need a lot more people to finish this. It's going really well, but the amount of content we've got is a tenth of what we need. We need to bring in some more people. And then at that point, Black and White had just shipped, and the classic problem, and Black and White, Lionhead at the time was 40 or 50 people. Peter had the problem of now having a large team of people who weren't working on a game, and so the natural thing was just to munge the two teams together, which was weird, honestly, because we had been in Godalming in our own office working on Fable for 3-4 years, and now Dene and I moved full-time to the Lionhead offices to go and help direct this team now of 40-50 people. We left most of the artists behind in Godalming. That created all sorts of tensions, because most of the decision-making was now happening in Guildford, whereas the artists were in Godalming. They felt cut off, completely understandably. Created lots of tensions, was not an ideal situation. And the last 18 months were also just super crunchy. It was 50 people working 6-day weeks, 12, 18 hours each day, just continually trying to get the game to ship. And again, thinking we can do this in 6 months' time. We can do this in another 6 months' time, and then eventually being forced to do it 6 months later, and just about putting it together.
Fable is so packed with systems, and now when you start the game and you, let's say, pick Unreal Engine, you have plugins, you have things you can use like libraries, you have components built into engine. For example, if you want to have story, like maybe they're not the best, but there's a set of tools that you can use, right? You have both the engine work and your coroutine system, for example, and things like rendering, like core systems, and then you have things like story, quests, economics that could be exploited. And I did exploit. I was thinking very smart. I can sell all. When I have a lot, I can sell all to the merchant, and merchant's like, oh, I have a lot. I bring the price down so I can buy back and then resell everything and just make infinite money. And all of these like systems and simulation, like, do you have tools for this? You mentioned scripting language. Macro basic scripting language as one, but all the other things for like content creation, quests, narrative, cutscenes, animations, like all of these systems, like who was doing that?
So that was largely Dene and the design team. I think the main tool Dene ended up relying on was, and I think we ended up adding an importer for this. He would use spreadsheets to go and set out all of the balancing variables with various formula to then feed into the main sheets. And then I think we then exported that as a CSV file and imported that as the economic data, the balancing variables for various parts of the simulation. And then that came in. So then Dene was then able to tweak parameters in the main sheet, and then that would then cascade into the secondary sheets, which then turned into the main sheets. So I think that's how he did most of the balancing. Cutscenes, we didn't do cutscenes in Fable 1. We skipped that by having the murals in the guild. So whenever there was a key storytelling element, we had essentially FMV of scanning the big murals that told the story of the hero.
Yes.
We would pass around those. Where we had important NPC interactions that just use our main conversation system. So that was just a standardized conversation system for that. But no, we intentionally eschewed cutscenes because we had no cutscene tooling, and didn't really for Fable 2 either.
Okay.
So yes, a combination of spreadsheets and bodging and chicanery.
Okay. and Dene and the design team was responsible for all of these, and you were on the technical side, on the engine side, okay.
Yeah. So the work split at the beginning of Fable was Dene and I were both coders and designers, and then we specialized about halfway through Fable, where Dene then focused more on design, working with the artists and working with the scripting team, and I focused on making it fit.
Okay. And the general direction was you discussing with your brother how should we run things, or was there like a leader for what form they should take?
We had, it was mostly led by Dene and myself. We had a management team within Big Blue Box, which was very small. But the one of the things I did learn through the Fable experience was that a team up to the size of about 12, 14 people, it's very easy to get everybody involved in decision making. Because there are enough people where you can get, you can couch lots of opinions and people could input constructively. There aren't so many people where you get arguments or you get miscommunication or things get noisy. So we at that point hadn't really had to then deal with the next level up of what do you have, the problems you then get when you scale beyond 12. So early days of Fable, it was very egalitarian. It was very people just coming up with ideas, people throwing out things. Yeah, that one's not going to work. It not being a thing. Lots of the design elements came from just people having fun with the idea. The naming of Hobbs came from, I think, one of the artists. We wanted a goblin type character in the game, but because we were always trying to be novel and innovative, we didn't really want to call them goblins. So we wanted a goblin, and we can have hobgoblins. And then one of the artists who was well read suggested, well, you could call them after Thomas Hobbes, who famously declared that life was nasty, brutish, and short. And so Hobbes, our goblins, became nasty, brutish, and short. In order to play into that pun. And it was just one of those things where somebody has a silly idea in a meeting, it then comes around, and then before you know it, it's a shipping major creature within the game based on a throwaway pun. And various things like that would just bubble up. It does have a massive downside though, which was we did the Fable 1 DLC. I think it was the V1 DLC, and most of the stuff in that, we had a huge warehouse of stuff in Fable 1 that we had thought was cool and then just didn't end up fitting in the game. Like, we had a whole dragon. We built dragons for Fable 1, which we then didn't end up using in the main Fable 1 because there was no story element for it. And the poor artist who had been working on that for several months, we had lots of things like that because we were planning as we were going, which in hindsight is not the best way to make a complex role-playing game.
How did the scaling from 12 to more people look like on the technical side and the engine side and scripting parts? And
it's a good question. It was chaotic, I think, because we had a fairly well-designed game code base. Because I had been brought up on the challenge you have when building a game code base is when to generalize and when to make things very narrow and focused, and balancing that out so that you don't cut off avenues while also not overgeneralizing for things that you don't need to, making things inefficient, is a hard one. Years of working at Bullfrog and through the kind of the Fable design process had given us, I think, a good instinct for how to architect a code base to be flexible and not force you to cut off sections without being chaotic. So it was a neat and well-maintained and well-curated code base. In particular, because we were using components, there were clear places where new functionality could live. The scripting language was a clear, separate layer. The rendering system was its own clear, separate thing. Where all the definition stuff for the entity is, that was its own separate thing. So it was all nicely, carefully managed and curated. And I think that just then helped when we then dumped on 3 times as many scripters. They have their own bit. We now have 3 times as many coders. Some of them are rendering, some of them are gameplay coding. You're working on these components, and it kind of then we just segmented relatively naturally, I think. That might also be wishful thinking on my part, and maybe it was actually just a lot more chaotic than I remember. But I seem to remember we scaled the tech relatively elegantly.
Okay. I'm assuming then I guess onboarding time was. I'm trying to think of, are there any lessons to learn on the actual like generalization versus narrow specification for the kind of problem? Like this is a problematic aspect, when you have a team and you have new people coming in and you say like, hey, this is how you're supposed to do things, or maybe there are better ways to do it, like that we do it right now. So I wonder, like, is there something that I can take as a feedback or like, lesson learned for doing these?
I think it's a very good question. And I think there are probably so many answers, or there are so many things that I've learned about that through brutal, poor experiences. One of them is definitely being clear on what is load bearing and what isn't load bearing in your code. And that's important for two reasons. It's very easy to start working on a system, and because it's the thing that you're working on, you feel it needs to be load bearing. This needs to be generalized. This needs to have a coherent API. It needs to be built for loads of other people to use. And then it ends up not being used by loads of other people. And so what you've then done is you've now fixed the surface area of this thing in a very rigid way, because you've determined how you think other people are going to be using it. And a lot of the time when people are deciding to do that, they're doing it. They're making the wrong decision. They don't actually know if it's going to be generalized yet. And then at the opposite end, you then got people accidentally creating a key piece of technology, which they initially wrote just as a throwaway prototypey piece of code, which then ends up being this load-bearing system that lots of other people are using, but the internals of it have never actually been coherently thought through. And one of the primary mistakes I've seen over the years is assuming something's going to be load-bearing when it isn't, or assuming something is going to be a leaf node bit of code when it isn't. But also, most importantly, the bits where those things transition, where you go from being, this is a bit of leaf node code, it's throwaway, it doesn't really matter, and then it becomes load-bearing. Often you don't see that transition, and then go and take appropriate steps. And this thing ends up having loads of dependencies, loads of things depending on it, and it's now too late to refactor it. And the only person who understands how that bit of code now works is this one very unhappy person. So kind of watching for that transition is one of the things I've definitely learned. And then somebody at DeepMind actually had a really good rule of three when writing systems, which was, I never generalize a system unless I see it being used 3 times.
Yeah.
Once it's been used 3 times, that is the magic point where I then go, oh yeah, this is obviously, there is now a pattern here I need to generalize. If it's been used twice, that is not a pattern yet. That is just 2 people using the same thing. Don't generalize yet. Once I see it being used 3 times, then fine. Let's take a step back. Let's refactor it, and then let's think about how it's going to be used. I quite like that. It gives you quite then an organic framework to look at things, because it encourages prototyping. It encourages you to think about your code base as this living, evolving thing, rather than either YOLOing it fully or thinking up front, actually, we need to go and plan out the next 2 years of coding. Let's sit down and do this on pen and paper. You have both, and they need to talk to each other.
Okay. Are we closing the Fable chapter now?
Yes, I think so. Yes, I see. Yes.
What are your thoughts or feelings about Fable 2026, the one that is coming out? Like it's a new production. I think you're not involved in it, right? It's a
yes. What
are your thoughts?
I have very few thoughts, and some of that is mostly intentional. It feels weird, because obviously it's a game I feel very emotionally attached to. I'm looking forward to being surprised by what they put into it. So there is actually a genuine excitement there about seeing. One of the curses of making games is that you never enjoy the game that you're making because you just lose all perspective. So the idea of being able to enjoy a Fable game is actually is genuinely very exciting to me. At the same time, it does feel a bit weird because it's a bit like driving past the house where you grew up and they've put on some extensions. And you're going, yeah, well, I'm sure that, yes. I'm sure that works. That's a good, that's definitely for the better. And you have an emotional response which is uninformed, but it just looks different and curious. So, yeah. Complex.
Okay. Now we transition to No Man's Sky.
Did you want to do anything on Fable 2 at all? Because I have a few hardware things on Fable 2. If you want to, or not.
Of course. Because I was under the impression that Fable 2 and 3 sort of iterated on the already established engine.
I only wish that were true.
Then tell me.
Fable 2, for various reasons, we completely rewrote from scratch.
What?
Completely different code base. There are complex reasons for that. One of them is that the Xbox 360 was a completely different hardware platform. So it had 3 cores and 6 threads, whereas Fable 1 assumed a single core. So we needed to re-architect the game quite fundamentally to take advantage of that. It had no hard disk, so all of this careful streaming work we'd done to go make the game fit, we could no longer do. And also importantly, Fable Peter, because we were now owned by Lionhead, wanted a single unified engine across all of Lionhead. And Fable was the game that was going to build that. So we started thinking about this in terms of, we need to go and rethink this in terms of a completely new game engine that will service all of Lionhead, as well as Fable 2. In hindsight, a huge mistake. We ended up just throwing away so much code and rebuilding so many systems. And it probably added a year to game development, which is unfortunate. But at the same time, it was a completely different hardware paradigm to be building for. The two main things were having the main game fully running on a separate core. So the main game would run on, I think weirdly because of the threading priorities, the main game ran on core 2 and the renderer ran on core 1. And then we had lots of background stuff running on core 3. But because we didn't have a hard disk, we still had the problem we had assets that just wouldn't fit into memory. So we instead relied on extraordinarily careful DVD streaming and prioritization, and an awful lot of compression. So we had, I was listening to the your interview with Fabian, I think it was, who did the crunch compression. And we had an early variant of crunch compression in Fable 2, where Mark Adani, who is, again, one of the smartest people I'd ever met, wrote a JPEG-like runtime decompressor for all of our textures, which we were mounting in memory, and then we would decompress on the fly into the main renderer from this compressed mount point, just to get the game to fit. And yeah, at the times, like, why are we writing our own compression system? Oh, but we have to, because otherwise the game isn't going to fit.
So how much you didn't have disk? So you had DVD, which is like 4.7 gigabytes, right?
Yeah.
Okay. And so entire game needs to fit in on the DVD.
Yep. And
then depending on where you are at DVD, you are either faster,
exactly.
faster loaded, or okay.
Yeah.
Okay.
And of that 4.7 gig, one of them is a layer switch, which required refocusing the laser, which took 200 milliseconds. So you never wanted to do a layer change on the DVD.
What's a layer change?
So the DVD, I'm not sure if it was a proprietary format, but the DVDs that the Xbox 360 shipped with, you had 2 layers that were pressed on top of each other.
Okay.
And so in order to access half the data, you had to do a layer change to go and access that second stream of data. But that layer change required the laser to refocus, which took time. In addition, the main issue with trying to stream stuff with DVD is the seek times, because your seek times are a minimum of 40 milliseconds. But if the data is far away, physically far away, you would have a seek time of 100 to 200 milliseconds. So again, it was kind of trying to make sure that all of the we would run an analysis on the game data to work out when we are streaming the game what data is likely to be needed adjacent to each other, and then we would stream in adjacent blocks we'd stream in too much and then use that because we're likely to need the next textures. Is all sorts of crazy things to try and make things stream in fast enough. But again, we were streaming meshes, animations, audio, the terrain, but now from something that has 200 millisecond seek time at its worst.
Okay, but so now you're architecting the game engine for like not only Fable 2, but all of other games.
Yes.
But you also have constraints of a DVD.
Yes.
And a platform like Xbox 360. But also at the same time, you know that like in the future there will be new platforms, and this will need to be adapted. So in hindsight, was this like good decision to try to do it?
I mean,
as a general purpose engine?
So the way we actually ended up separating it out was we separated out the editor from game logic from rendering code. The rendering code was mostly shareable. The game logic was entirely bespoke to Fable. And then we had this editor, which was written in C#, I think, which was a standalone, completely different editor. The editor for Fable 1 was baked into the Fable 1 code base. It was all C++, used our own GUI primitives to go and render the editor. This was the new world of running proper editors. So we built one in .NET, and that was relatively agnostic. So it would be generating XML data, which you could then compile into the game-specific data. The idea there being that your editor would then be this shareable thing. We could then have modules within this editor, which could be shareable between games, things like mesh formats, mesh rendering, level formats, etc. But then each game could write its own rendering logic and its own game code if it wanted to. And then in the middle of this, we had this very... I'm going to use the word advanced, but I will revise it later. Asset build system, which was genuinely amazing. So it was based on scones initially, and then we refactored it ourselves. And you expressed all of your asset graphs as dependencies, and it would automatically work out what to build. It would cache stuff on the shared network, with the idea being that you then author stuff in the editor, run this asset build, that would then translate to whatever formats you need to translate it to, and then you'd run your game. In theory, lovely. In hindsight, we really relied on that dependency system far too much. As an example, you'd have the terrain in Fable. It would have as one of its dependencies the textures in the game, and it would have as another one of its dependencies the foliage definition files. Because in order to go and bake out the terrain as the correct meshes, it needs to know about both those things. What this meant was, in effect, somebody would go and tweak a text file somewhere up here, and 4,000 things would need to be rebuilt the next time somebody synced. And you never knew how you'd sync and just be in terror of have I now just triggered a 45-minute unintended cook time just because somebody's tweaked the size of a daisy over here. There are things decisions were made, mistakes were made, and we should have revised that. But it was a beautiful system in paper.
I heard lots of good things about tech at Lionhead, from Stuart Lynch, for example, and
Yes.
Stuart
Stuart wrote this assets database system, which was extraordinary. We abused the hell out of it. Is the problem?
I'm thinking, like, when you're working on these tools, you need to have this mentality of like, hey, I am shipping a game. I have very limited resources. Okay, like, is it worth my time spending my time to architect a system, and then like how to gauge whether this is the useful thing to do now?
Yes.
Was this the process for this from your end?
There was not, and I think the two answers to that answers the question. One is that the editor, this componentized editor, was being built by a core central technology team. So they were not on the Fable team. They were building the editor for everyone, which in theory should give you the benefit of them having then the headspace to go and think generically, and then we benefit from having this generic editor, which we can then customize and have this asset build system, which then makes it specific for our use case. In practice, you then have two different teams with completely different priorities who aren't really talking to each other, and they are thinking long term, and they are thinking the big picture. We are thinking, we have E3 coming up in 2 weeks, and undo doesn't currently work. Can we have undo, please? And having no coordinated priorities between these things was a big lesson I learned about the dangers and challenges of having a central technology system, a team. And then the other answer to that is that the Fable team was fully focused on Fable and its needs and the next E3 demonstrating to Microsoft. And so we ended up not really contributing. We didn't end up thinking much about the generalized use case. And so actually this whole generalized editor thing did not really take off in Lionhead. I don't think any other game in Lionhead actually ended up using it.
Okay. So are there more lessons in terms of Fable 1 started as like a couple of you two, and then 12 people, and then at some point 50 or even 60 people, and then Fable 2 starts off, I'm assuming, with like this larger team.
Started off with about 40 people. Yeah.
Structured differently, and then there's more communication, which means like depending on the communication pipelines, like things can go wrong, and like having contrasted these two style of development, is there something that you prefer, and then what do you do differently in these environments?
Yes, very good question. Fable 2 ended up, I think, having 120 or so people on it. It was at the time it was enormous. I think we ended up structured things fairly well. We were cognizant of the challenges we'd hit with scaling in Fable 1. So feeling like a single team, having clearly defined leaders for each discipline worked very well. I focused entirely on tech, and I led the tech team. I then had various leads of rendering, gameplay, etc. And that all scaled well. Within design, you had Dene and Richard Ham, who shared a design leadership. Again, they had a big team, and I think Dene focused mostly on scripting, and Richard Ham focused on bigger design things. So that scaled out quite well. So I think we structured it quite nicely. I think it also highlighted that inevitably, once you do scale to that size, it's very difficult to pivot. It's very difficult to that chaotic, energetic, passion-led development that had been throughout Fable 1 we could do that because we could pivot really quickly. We could throw ideas at walls. We could listen to people. We could riff. It's very difficult to generate that same sense of passionate creativity with 125 people, or with 2 teams that don't actually know what each other is doing. Or actually, a good example of that is in the tech team, we built Fable 2 used Lua as its scripting system. It was a bespoke Lua VM, and we wrote an API for how we thought scripters should use it. We then gave it to the scripting team, and then, okay, that's the scripting team done, and we'll maintain them. We'll then go and do bug fixes and things like that. Let's go and focus on now performance and all these other game features and things like that. We then looked back 6 months later and we go, oh my God, you're using coroutines as your event system. Because we didn't give you a good event system, what you instead have is you have 900 coroutines spinning, checking a variable to see if it's changed yet every frame.
Oh, wow.
And you came up with that system out of necessity, and it works you, it unblocks you, but because our 2 teams were not talking, you felt it was necessary to build that system. And it's just, it's a great example of how you think these 2 teams are talking, but unless you're actually sitting with them, you don't know quite what's going on. So yes, maintaining communication hierarchically kind of worked, but you lose that organic people riffing. The coders end up feeling like they're not really creatively empowered. The artists felt like they didn't have any input into tech particularly, or how rendering should work. And you end up with a different set of communication barriers between the teams, which again, there are ways then of fixing those as well, but we only notice these after 2 or 3 years of experiencing it. And my general feeling is that I think I personally much prefer working on games that fit with smaller teams because it's more fun. It is less fun, from my point of view, as a person who got into games for the creativity and feeling like I am making this thing that we are all participating in. It's a lot less fun if you do feel like you're steering an oil tanker, because the decision making is then all 6-9 months out. It's all top down. It's all hierarchical. It's not organic, and it is much more fun from my point of view to work organically and work with other creative people to build the thing together. So the thing I learned is that I prefer small teams and things that can fit, making active choices to make things fit into smaller teams, which incidentally is one of the things Sean at No Man's Sky, hello, that is one of his guiding principles as well. Keeping a team small enough that everybody feels like they are part of that thing. And a lot of No Man's Sky is designed around what can we make with a team that is this small. How do we keep the team? Let's design our games that we can keep the team this small so that we don't experience this complexity that then leads to rather stodgy decision making.
Because I was about to ask, like, is it possible to like deliver the AAA high quality games, but within a small team, within like up to 10, 15 people? So I had no idea that No Man's Sky team is this small.
So when I was working on No Man's Sky, I think it was 15 people, and that was the biggest it had ever been.
Oh wow! Okay.
And that's where all the prop gen comes from. We don't have the people to make variety. Let's use the computer to make the variety. We don't have the people to do scripts. Let's think of a high level reward system that doesn't require content scripting per se. And it all kind of flows from that decision making process. To answer your question, though, I think better tooling does allow you to make bigger games. Like Mixtape, which I played recently and loved, feels like a AAA game made by a small studio. Took them quite a while. It's very content rich, but that's only possible because it also does feel like they all had fun and creativity involved in it. It feels like a very vibrant game. And I'm imagining that's partly possible because they use Unreal, they use good tools, they could make it with a smallish team and therefore all have a voice.
Nice. Do we have things on Fable 2 and 3 on the list?
No, the only thing I was going to mention about Fable 2, the only other thing I was mentioning about Fable 2 was our link times. Link times at the end of Fable 2 were 5 minutes. And all of that was because of debug symbol. It was merging the PDBs. And the only way people could fix it was by turning PDB linking off. So people could not debug the game. They would be running it, then it would crash, and then they'd just get raw assembler going, think that's okay. Let me go and turn debugging on that one function, and then repro the crash.
Per function. Debugging turned on per function.
So turn off the debug symbols, then turn it on for that function and its call stack. Because I don't quite know what went wrong, but our debug symbol merging, 5 minutes each compile. Insane.
How generally the compile times look like on Fables?
So with Fable 1, it wasn't so bad, and we ended up using Incredibuild, so in the order of minutes. Fable 2, because the PowerPC chip was RISC, it was very compiler optimization sensitive. So you had to mostly build the game in release builds, which slowed down compilation. So I think it probably took, I think compilation with Incredibuild ended up taking a few minutes, but then the unavoidable link step would always bite you. So probably iteration times of up to 10 minutes.
It's rough. That's rough.
Yeah.
How big was the source code? Do you remember, like?
It's a good question.
Lines of code, kind of.
I don't remember. No, I don't remember that. It was. I seem to remember it being. This is a bit of a guess, but certainly around 1 million.
For Fable 2.
For Fable 2, I think. Maybe larger. The thing that just popped into my head is that for Fable 1 HD, I just remembered, the way they did Fable 1 HD was they had the entirety of Fable running in a thread within the Unreal Engine, and what Fable 1 would then do. They would be running the entirety of Fable 1 running in a VM in a core on Unreal Engine, and then it would emit the primitives that it needed to render, and then they listened to that with the Unreal Engine, and then just drew what Fable 1 requested. So it was a byte for byte exact replica of what the simulation of the game wanted.
Okay.
The reason I'm remembering that is I just remembered that the person who did that, they ended up, because it was the first time the Fable 1 code was then being pushed onto Microsoft's source control system, it was the first time the code had to be legally approved by Microsoft. What they had to do with that was then going to run all of the comments through profanity filters and things. And so what we ended up with this senior coder having to send a list of all of the profanity in all of the Fable 1 code base to a lawyer to have it signed off, so that the code could then go into Microsoft's source control system. So it was just this email which was just laden with just frustration and very sweary comments.
Why couldn't they be deleted?
I can't quite remember. It wasn't just comments; they were in the function names.
Oh, nice.
We had a lot of sweary function names. Yes,
nice.
Which is what happens when you're frustrated at 1
when you're working like 18-hour days. I can imagine,
yes.
You know. So from Fable 1 to Fable 2, you pretty much had order of magnitude ramp up in like people, in team size, in project size, in compilation times. Fable 2 to Fable 3 was the same?
Nope.
Oh,
Fable 2 to Fable 3, we set ourselves a goal of we will ship another game in 2 years. And we will design the game around that, because the first game took 6 years, the second game took 4 years. Microsoft would quite like to have another Fable out this console generation. Let's design the game around that. So we set ourselves very strict requirements to only iterate and not change too much.
oh, okay. So technically, you tried to limit the work on the engine and foundation to have more on the content and iteration. Okay.
Exactly.
Okay. Okay.
And so we did add some new tech around lighting and shading. I think in Fable 2, all the lighting was pre-baked per vertex, and I think for Fable 3 we did it in textures instead. Various things like that. Depth of field, I think we added as well. Yes, so various technical iterations there, and then mostly content and performance improvements and things.
Okay. So this is now when we enter No Man's Sky,
Yes.
right? Tell me, when did you join? How did the project look like then?
So I think we can probably go relatively quickly over No Man's Sky, because I was only there for, I think it was a little under 2 years. I joined because Louise Murray, who was our product manager on Fable 1 and Fable 2, and the head of studio for the Fable team, her husband, Sean, was working on No Man's Sky, and they were looking to ship, and I had similar experiences shipping Fable, making things fit. And so, yes, I jumped on board and helped out those last 18 months, 2 years.
Okay. Well, so you were mostly concerned with like optimizations and thinking about how to cram the game into.
So when I joined, the game was a PS4 exclusive, and it ran on the PS4 at the time, but at a very low frame rate. And I think it needed a lot more memory than a PS4 has. So the main focus was on just trying to make sure the PS4 version was going to be shippable on time, and in particular, making the challenge with No Man's Sky is that everybody knows it is all procedurally generated. It is difficult to understand what that means until you experience it, because, and particularly if you've not worked on a game that is as procedurally generated as No Man's Sky. What I mean with that is that obviously when you are on the planet in No Man's Sky, the terrain around you is generated. What is not obvious is that when you get a signal marker on the planet over there, in order to get that signal marker to appear in the right position, you have to generate that planet and the patch of terrain around it, and then the buildings that are on that patch of terrain, because that building will flatten the terrain. And then you have to go and work out what type of the terrain is, generate all the terrain and generate all the noise, in order to then go and work out the position and whether or not that marker can even actually exist there on the fly. And throughout No Man's Sky, you're kind of like, oh, I'm generating terrain. Oh, but now it needs to go and generate this bit over here, which is, and it's just crazy. None of it exists until it needs to exist. It exists on demand, and then it is kind of conjured from the ether as soon as you need that for a speech bubble or something. And so trying to get that running on a PS4 is very hard, because it's a good CPU, but you're running so many threads of procgen to generate the height fields, to generate the textures, to go and generate vast levels of Perlin noise, and then all the foliage around it. It's just so many layers of procedural generation. So one of the main bits of work there was a very clever chap, Chris Cummings. He he had worked on Dreams and had written the physics system for Dreams. So he had a lot of experience of running things you wouldn't have normally run on compute, on PS4 compute. So he ported a whole bunch of the No Man's Sky proc gen stuff so it would run on compute and run essentially on the GPU on demand, which saved our bacon. The other big problem of proc gen is that old wonderful thing, determinism, which is that one of the key points of No Man's Sky was that any given seed should give you the same universe, and then you should be able to take a coordinate and go to that exact spot and see exactly the same thing that anybody else should be able to see. That requires the entire prop gen system to be deterministic between the PC and the PlayStation 4. And there were so many subtle determinism bugs that you then have to go and track down. My favorite of those, I don't know if it was because I'd worked on Windows platforms almost exclusively until then, because Xbox is essentially Windows and whatever. But PS4 obviously is runs GCC, whereas on PC they're running Visual Studio and the MS-DEV compiler. Subtle compiler differences. My favorite one of which is undefined behavior around. Did you know this? It is undefined what order parameters are called in C. So if you have a function and it takes A and B, on Windows, I believe, it evaluates A then B. On GCC, it evaluates B then A. So this is problematic. If you have a function which is procgen terrain and you pass in color A and color B, and color A and color B is generate random color A, generate random color B. The ordering is switched depending on which platform. It took me days to find.
Wow. I had no idea. It must be a pain to develop a same project for different platforms. That's already like issue. But then like it's just like more work to think of. And then you have two different compilers.
Yes.
Which is like, not fun.
Yes, two different compilers that have subtly different interpretations of what the standards are. Yes.
Was it then... okay, so I understand No Man's Sky as this premise offering this like infinite world, then release of the game, huge letdown, and then a massive comeback couple of years later, delivering on this promise that was then like back in the day zero. In what like span of the time you were there before the release and trying to like cram in the No Man's Sky build in the PS4?
Yeah, so I was there for the release and then for another 6 months or so, I think. To help land the first big content patch, which is the first part on the path of delivering all things that have been previously promised.
How then how would you recommend people starting with optimizations for PS4 roughly? Like imagine you have a complex project. You mentioned this is a very unique project because of the proc gen thing, but is there something that you can take away from this experience that could be applied into other situations where you would have a complex thing and you want to now ship it on the PS4, which is, I would say, it's very limited on the hardware side, but at the same time, it already resembles the CPUs we have today. It's not like a single core machine or something.
Sure. Yes, good question. I think the advice is always don't make assumptions, profile first. And I think that is generally very good advice because certainly, I think the first big thing I optimized in No Man's Sky was, again, it was actually it was either a compiler or a macro variation between the two, between Windows and PC, where on Windows, a string was being passed by reference, and then on PS4 it was being passed by value, and this was in the shaders. And so you ended up with just loads of mem copies. And without a profiler, you'd have never seen that one and never guessed it. So profiling first is very, very good advice. For every game I've ever tried to get to fit, I have always ended up writing my own profiler and my own memory tracker. Just because you end up wanting to focus your attention on very specific things a lot of the time. And in a lot of profilers, you end up, either it's a sampling profiler, in which case you can't really direct it quite enough, or it's an instrumenting profiler, in which case it throws off all of your timing generally. So I've almost always ended up writing my own timing system, which then exports out to some kind of visualizer. For memory, it's crucial though, because you want to know where every single byte is going on a console, and finding out that this particular system here is using up 8 meg when it shouldn't be. Trying to find that, and also then track memory leaks and do deltas, is super hard otherwise. Some tooling for the PS4 has gotten better for that. For consoles has gotten better for that over the years, but in general, be able to track memory leaks is super hard unless you have your own tooling to visualize that. And then the other bit of advice is, if you are profiling first, it often puts you into a mindset of, this thing here is slow. How do I speed it up? If you're not careful, you end up then asking the wrong questions and missing the question of, does this thing even need to be, what is this doing? Does this even need to be used? What is this for? And in a lot of the cases, I was there kind of, optimizing the prop gen for No Man's Sky and trying to make it faster. Because this thing was appearing, it was causing a stall, and it would go and cause a generation thing here. And it'd take me 2 weeks to ask, hang on, what is it that's actually triggering the proc gen for this actual thing? Why are we even doing it? Oh, we don't need to do it for this at all, do we really? We could just go and have a proxy thing for it, and that doesn't actually matter. Good. But it's very easy to get myopic and fall down a rabbit hole and forget to kind of step back and go, are these things actually even needed? Why is this thing even being called? And then certainly on modern hardware, it's less being careful of things like your memory access patterns, cache lines, all the standard things, which interestingly, when I first started out writing games, were not a thing. When I was doing Dungeon Keeper, when you were optimizing, it was all about raw CPU performance. Memory was irrelevant. And then that kind of switched around the Xbox 360 era, where you need to be very careful about your memory bandwidth and your various memory caches. But yeah, back in the old days, memory bandwidth was not a thing. It was just it was all compute band.
Yeah. Okay, that's interesting. Yeah. Nice. Now we're 2 hours in.
Yes.
And we still didn't open DeepMind chapter. So
yes. You were correct. We passed the time.
So let's have a DeepMind chapter at another meeting, and please tell me and everybody else, is there a place to follow your work now? What, do you have a blog that you have? Or
yes, I do. I have a blog that I intermittently post to at blog.simoncarter.me. And I'm BBB Scarter on Mastodon and on Blue Sky.
Nice. I will put the links in the description. And then we meet for another episode for
yes.
Google DeepMind.
And also we should talk about Moonring as well, which is the next game that I'm working on with Dene, which is semi-fably and all kinds of different exciting.
Okay. Nice. Awesome. Then we'll have this in the episode number 2.
Wonderful.